Hello my dear students, in the last class I explained about thin cylinders. Today we will discuss about thick cylinders. What is this thick cylinders? Thick cylinders are the cylindrical vessels containing fluid under pressure and whose wall thickness is not small. Means it is T is greater than or equal to D divided by 20. In the case of thin cylinders, the thickness was less than D divided by 20, but here it is thickness is greater than the 120 times of the diameter. Okay, and in a thin shell, the stresses are assumed to be uniformly distributed throughout the wall thickness, but it is not so in the case of thick shells, and it varies with the thickness. Okay, in the thin shell, it was what assumed, we have assumed the stresses are uniformly distributed throughout the wall thickness, but in the case of thick shells, it doesn't happen like that. It varies with the thickness, and also unlike thin shells, the radial stress in the wall thickness is not negligible. In the thin shells, we have ignored the radial stress because it is very small, but in the case of thick shells, we cannot neglect the radial stress. Okay, and rather it varies from the inner surface where it is equal to the magnitude of the fluid pressure to the outer surface where usually it is equal to 0 if exposed to the atmosphere. Means there will be radial stress here, inner surface also, outer surface also. Thick shells are generally used to withstand high pressures. Sometimes even compound thick shells are also used to withstand very high pressures or to contain chemicals under high pressure. Okay, thick cylinders are mainly, it is what we can say means it withstands high pressures. Okay, because its thickness is greater than the diameter. Okay, and the variation in the radial as well as circumferential stresses across the thickness are obtained with the help of Lamins theory. Okay, see in the thin cylinders what we have calculated, circumferential stresses and longitudinal stresses using the simple formula, right? What is that? PD divided by 2T and PD divided by 4T. But here the variation in the radial as well as circumferential stresses are calculated using the help of Lamins theory. What Lamins theory? It is used to, Lamins theory is used to solve thick cylinder problems. The problem of thick cylinder is somewhat complex and it is solved in the following assumption. Before applying Lamins theorem, we should have some assumptions. What assumption? The first one is the material of the shell is homogeneous and isotropic. This is the common assumption in all the theories. Okay, the material is homogeneous and isotropic means material is made up of similar materials and also it is same in all the direction, that is isotropic. Then second one is the plane sections perpendicular to the longitudinal axis of the cylinder remains plane even after the application of internal pressure. This is the second assumption, means plane section remains plane even after the application of internal pressure. That is, the longitudinal strain is constant and is independent of the radius of the shell. Next, third one is the material is stressed within the elastic limit. Okay, so means it should obey the Hooke's law. What Hooke's law says? The stress is directly proportional to strain within the elastic limit. So this also says same thing. The material is stressed within the elastic limit. Then the last one is all the fibers of the material are free to expand or contract independently without being constrained by the adjacent fibers. Okay. Means here the fibers of the materials are free to expand or contract independently without being affected by the adjacent fibers. So the theory derived after the above mentioned assumptions is popularly known as Lamins theory. Okay, so thick cylinder problems are solved by using the Lamins theory. So now let us consider a thick cylindrical shell subjected to an internal pressure as shown in the figure. Okay, now let us consider one cylinder, okay, hollow cylinder of the radius R1. In outer radius is R1 and the inner radius is R2. This is one cylinder here, can see, and this is the other cylinder. Okay, so the radius, this is inner radius here. Here to here, that is R2, and outer radius, that is from here to here, that is R1. Outer radius is R1 and inner radius is R2. Here I have written R1 is the outer radius of the cylinder, R2 is inner radius of the cylinder, L is the length of the cylinder. Okay, now consider an elementary ring of the cylinder of thickness dx and of a radius x as shown in the figure. Okay, here now let us consider once this elementary ring of the cylinder. This is one consider, just okay. Here this thickness it is assumed to be dx, okay, and which is at a distance, this elementary string which is at a distance of x from the radius here, from x, okay, this is dx. Okay, now how these pressures are acting, here you can see this Px is intensity of pressure on the inside of the ring. So inside the ring the pressure, this is intensity of pressure on the inside of the ring, okay, Px. Then Px plus dPx, that is intensity of pressure on the outside of the ring. This is not minus, this is plus, okay. Here Px plus dPx, that is intensity of pressure on the outside of the ring. So here this pressure is Px plus dPx and inside that pressure is Px. Okay, because now we have considered one string here which is at a distance of x from the radius and this is dx. Okay, so outside pressure is Px plus dPx and inside pressure is Px. Okay, now sigma x is intensity of hoop stress induced in the ring, that we have to calculate. Here the derivation is there, you can go through this, but it is not important. You just know, you should know how to calculate the pressure, circumferential stress and radial stress. For that you require only this formula, that you remember. You can go through the derivation, okay, if you are interested, just go through that. But I want to solve the problem. You have to remember only these two problems, these two formulas, that is Px radial stress, that is given by the formula B divided by x square minus A, and circumferential stress, that is sigma x, that is given by B divided by x square plus A. Okay, this is actually, this is the equation Px. If you substitute in the equation 4, means this is the equation 4, sigma x, you get Px plus 2a. Px is this, B divided by x square minus a plus 2a. So simplify, you get b divided by x square plus a. Okay, so finally you just remember these two formulas, that is Px, that is nothing but radial stress or radial pressure, that is given by b divided by x square minus a, and radial stress, that is given by b divided by x square plus a. So I have written here radial stress Px is b divided by it, you can write in terms of r also, radius, okay, r square minus a, and circumferential also called as hoop stress, that is given by sigma x is equal to b divided by r square plus a. Okay, these two formulas you remember, you can solve any type of problems. Okay, and some notes you have to remember, that is, the first one is the values of a and b in the above equation are evaluated from the given conditions. Okay, the above two equations means you have to solve that by using the conditions. A and b can be calculated by using the conditions, and the above two equations we 5 and 6 are Lamins equation, that is these two equation. Px is b divided by x square minus a and sigma x is b divided by x square plus a. These two equations are called Lamins equations, and it should be remembered that the values of Px is compressive and that of sigma x is tensile in the above two equation. Okay, this radial stress is compressive and tensile stress is circumferential stress. Now, intensity of pressure outside the thick cylinder is taken to be 0. Always the intensity of pressure outside the thick cylinder is taken to be 0, though it has some hoop stress due to pressure inside the thick cylinder. Although it has some hoop stress due to pressure inside the thick cylinder, we have to consider intensity of the pressure outside the thick cylinder is 0. Okay, now these are the some of the assumptions, notes you have to remember. Okay, so just remember this, you can solve any type of problems. In the next class I will solve the problems. I hope all of you understood. Thank you.